And here we are with the old Weaky low power 383, and it's time for me to cut those pistons. So that's going to be something to see. You guys tell me, what do you think? Is it going to work? We're going to find out. Let's go. Here we go.
Nick's Garage is supported by Atlas Equipment and K-Tool International. Welcome back to Nick's Garage and the continuing saga of Old Weaky. Make sure you've watched the previous episodes in this series, as Nick and his team have worked through a process of elimination, trying to determine why this classic 383 V8 isn't producing the torque that was claimed by the factory back in the day. Last time we saw the engine, Nick was facing the choice between buying new pistons or modifying the existing ones in order to make clearance for the valves after having upped the compression. Now Nick is back with the engine once more, and this time he hopes to finally close the case of Old Weaky, the low power 383.
Hi, I'm Nick, and welcome back to the continuous work on the Weaky 383. I've seen everybody's comments. I read as much as I can, but I understand. You know, people are asking me, is the cam degreed in? Yes, the cam is, I did not degree it in. I just checked it. It's at 107 intake centerline degreed in. So it's not that. And we, of course, like I said, we went back to the bullet cam. And also, I've also spoke to Joe. Joe gave me a call and said, Nick, if you need to replace the pistons, go right ahead, change them. So we might blow the budget a bit. Why not? But the question was, can I find the pistons I want? I found dish pistons, dome pistons, cast pistons, pistons way below the deck. But then again, they might be on their car like what I want, but none of them have them in stock. I checked with Ross, Diamond, Keith Black, SRP. So they don't have them. So you know what I said? These pistons are almost what I want. They're forged, they're flat top, they're almost near the deck. All I need is a little cut valve relief for the intake valve. I just needed about 40 to 50 thou more clearance, but they were not touching in the first place. The intake valve came pretty close. I wanted to add about 40 to 50 thou more because being a 4-speed car, non-rev limiter in the car, maybe you might miss a gear revving it high. I just wanted to make some assurance that that big intake valve does not hit the piston. What I'm in the process of doing is what I've done to my brother's engine back in the day with the 360 Magnum that he used to go racing. You know, on this engine, I made some, at the machine shop, valves to cut the valve reliefs or eyelids in the pistons for the clearance. But all they did was scratch the piston. I wanted to dig in about 40 to 50 thou, but I pushed and I spun the drill. They didn't work. You know, I thought they might work, but it didn't work. Then in the past, many years ago, on my brother's race 360 Magnum, we bought these. They were valves with welded cutters on it. And we had this done in the car. We had the cylinder heads. You know, my brother decided to change the cam. Then, of course, we did not take the engine out of the car. All we did was change the cam, take off the heads, and we noticed that we didn't have enough clearance on the intake and exhaust. So what we did is we had the pistons cut, or should I say trimmed, while the engine was assembled in the car. Yes, it is a bit messy, but you gotta know what you're doing. So these were exactly the size of the valves they were for the 360. So since these are not what I want for the 383, and these did not, unfortunately, did not work for me. I went with, let's say they're called Lindy Tool Company, and got me this cutter. Now it's the latest model, and you know, I told him what I want to do, and he goes, Nick, we've done a lot of these cutters. You know, you just give me the valve size, the valve stem, and about a 35 thousandths outside diameter to give us also the side clearance. And the depth will be controlled by this collar, which I'm going to demonstrate in a few minutes how we do this job. Yes, it is messy, it is aluminum, but you know what? Removing a small amount of aluminum does not unbalance the engine. It doesn't not need to be rebalanced. And it's only a small cut, which I'm going to make in a few minutes. And you know, even aluminum cannot damage engine. You know, if it was cast iron, and if it gets stuck anywhere, it could scratch the lobes, it could scratch the cylinder walls or whatever. But aluminum is soft metal, and you know, there is no danger. But I do cut them in the block, which I'm going to show you in a few minutes. You know, we're going to put the piston atop the center. We're going to put wheel bearing grease in the groove, put the head gasket on, put another cylinder head on right here. It's not the ones I'm going to install on the engine. It's another set that's a scrap set of heads that I'm going to put the, what you call the piston cutter in it. And then one by one on 4 cylinders, we're going to have to remove the head 4 times. But I'm going to show you how it's done because after all, like I said, I did not find the pistons I want. So the only choice I got is this. Yes, it's a lot of work, but it doesn't matter. You know, I just want to show you guys sometimes when you don't have a chance of getting what you want, there's things they're doing out of the box, which I've done in the past. Sure, some people are going to call me a hacker, call me what you want. But you know what? I'm going to do it. I'm going to throw it in the dyno after, and we'll start testing it and take it from there. Like I said, I'm just trying to get a little bit more torque out of this engine, and it is a 3.3, because when this engine came here, it didn't have the power I wanted. I only wished I dyno tested the engine before I took off the cylinder heads. Now these pistons were never removed from this engine, and I said I never wanted to touch the rear seal. It didn't leak. It stopped leaking on its own, so it's good. I'm leaving it alone. So all I'm doing is playing with the cylinder heads and the cam. So like I said earlier, we also installed the, like I said in part 3, we installed the bullet cam that made 20 more horsepower. Torque numbers were the same, but this bullet cam made 20 more horsepower at the higher RPM level. So we put back the bullet cam. We did break it in. There was no wear or tear on the cam loads whatsoever. So now our job is to put a notch in the piston or a valve relief for the clearance on a new set of cylinder heads. And then we're going to see what happens on the dyno. You know, I already proceeded working on this last night. I've done a few, but I've left a few that I have not done so I can show you viewers. If you look on the other side, I've cut all 4 pistons on this side. Here's an example right here. I went about 50 thou down. Like I said, I have enough clearance. I don't need too much. It's not enough material to say that you really need to balance the crankshaft. And also, I also had a question to tell me that, Nick, the pistons on this side, right side bank, were higher than the left side bank. True. And they said maybe the 4 pistons are in the wrong rotation facing back. They're not. If you guys take a good look here, they all have arrows and they face the front, like so. So if you want to say what really happened is when the company or the factory, when they decked the block, didn't do very good when it came to decking. You know, I fought a few of that in the past, but anyways, it doesn't matter. And we're going to balance it out in a different way in a little while. All right, I'm just going to make a little demonstration. What does it take to do a job like that? It won't take long. We're going to start with 1 cylinder. I only got 3 cylinders to do. So I want to do a couple with you guys and see what it takes. First of all, we have to start by putting the piston top dead center, like so. Okay, so we're at top dead center. Take this off. Put the shim gasket that we are going to use, like so. Wait a minute. Before we do that, we're going to get some wheel bearing grease, which are right here. You're going to fill in the crack where the piston and the cylinder block on the very top, because you don't want those shavings going down into the rings. You know, after all, you want to remove these pistons and get them cut at a machine shop. They asked me to remove the connecting rods off the pistons, but they're press fit. And in some cases, when you remove them, they're pressed off. If you do remove the piston, you might crack the piston. So we don't have any other pistons right now. So my dilemma, the only thing is let's do it in the block. You know, I've done my brother's engine many years ago on a 360 Magnum, and this was a race engine. And he used to race it every weekend on a black Duster with a 360 Magnum. Yeah, he had a big cam. We couldn't find much of a choice of pistons. So what we decided to do is put some notches in it, and the job was done. So here I am years later doing the same in this situation. So here we go. So you see, you fill in the gap, make sure because you know cutting aluminum is going to make a lot of shavings. So this is what we do now. Here we go. Got a top dead center, got the grease, wheel bearing grease into the opening between the piston and the cylinder wall, so no shavings going into the rings. Got the thin head gasket, and now we take the cylinder head right here, which I'll show you what we have to do. And this is cylinder number 1. We take our cutter right here. I'm going to put it into the cylinder head. Then I'm going to put the collar, and I'm going to show you how to make the adjustment after for the depth so they're all consistent. Here we go. I'm going to put this in there like so. I'll put all these cutters on the side. I'll take the cylinder head, take it like this. There we go. Take a head bolt, put it like so, and you tighten it in place. All you need is one head bolt. It's just to hold the head from coming off. There we go. Then I want to go down about 40 to 45 thou down. This is how you do it now. Now you take your cutter and you let it touch the piston. So you know now that it's touching the piston. But you want to go down, let's say now we want to go down 50 thou. You take the collar, you put this on top of the valve guide like so. There you go, that's our 50 thou clearance that we're going to cut into the piston. Then we tighten the collar. There we go. No, not exactly there yet. I'm in no rush, I'm going to take my sweet time because I want to be consistent on all the cuts. Like so. There we go. So here we go. Put a filler gauge at 50 thou. Remove it. And now we got the depth at 50 thou. And now we start cutting. So we take an electric drill. You go clockwise with it. Like so. Then you take your sweet time. Here we go. Okay, now we take it off. You know when you bottom out that the collar touches the top of the valve guide, because we use the filler gauge to put it at 50 thou. So putting it at 50 thou gives me the depth I'm cutting into the piston. So as you're trying to push it, it won't go any further because the collar is touching the guide. Before I had a filler gauge at 50 thou, they gave me a gap. So the only thing you travel is what you have at the gap. And then we took it down and it should be there. So let's take a look. All right, now let's see what we've done. Okay, here we go. Now I'm going to take off the cylinder head. Now you guys are going to see a mess. Here we go. Oh, wait a minute. Here's my pry bar. there you have it. Okay, so there what you're looking at is that there's no shavings in the next cylinder or the adjacent cylinder. So now what I'm going to do is tilt the engine so when I pull up the head gasket, that no shavings go spread it anywhere else. So I do this, like so. Now I bring it down so like so, like there. And then you take off the gasket. Of course, you got to clean the gasket. And we're going to clean every piece because you know what? You're going to reassemble everything and go into the second cylinder or the next cylinder. So let's say we got to remove the head 8 times doing 8 pistons. So let me just put this here on the side. Okay. Okay, and then we do this. You notice that most of the shave is stuck on the grease. You know, I did it in my brother's engine. We ran it for many, many years and we had no issues whatsoever. And with that engine my brother had, he's won quite a few races, let me tell you. If anybody's been in Naperville with the 360 Black Magnum, or should I say Magnum 360 Black Duster 1974, my brother Phil raced it in Naperville for many, many years. And he's won many races with it. And yes, that's the one I did. Double notching or fly cut both sides, intake and exhaust on his engine. This one here, only a little bit on the intake. That's all we need. You know, why change the business for something small like this? You know, now I'm going to turn it over. Then I'm going to use a filler gauge to clean the gap, like so. So we got a filler gauge. I'm just going to stick it in here and try to remove as much as I can of the grease. And of course, we don't want any aluminum anywhere. It's like so. And when I pull out the grease, there's no shavings in there whatsoever. See, that was easy. You know, if that was cast iron, it would be a little bit more difficult if we have any of those shavings in the block. Because cast iron, if it falls anywhere between lifters, cam lobe, rings, cylinder wall, yes, it will make a scratch. Aluminum, very doubtful. There we go. Like I said, all I need was 40 to 50 thou insurance, which I have done. You know, like I said, they came very close. The exhaust I had enough clearance, but the intake had about 70 thou, so I wanted to add about 40, 50 thou just for insurance. And now I know when I put this engine on the dyno, I'm going to rev it. I'm not going to worry about it. And then again, you know, as the engine ages, years after years, the valve springs get weaker. And when you rev it high, they're not going to react and close those valves or open those valves. I mean, close those valves as fast as they were, as if they were new. So this is the reason why we do that. So 10 years later, if you're still driving the car and you miss a gear, you still have insurance that you're not going to hit that valve. There we go. And now I can proceed to the second one. I've done the last one also. So now we got 2 more left. And after that, all I have to do is assemble it with a cylinder, a fresh set of cylinder heads, put it on the dyno, and hopefully it does well. After all, I'm going to put it with headers. You know, I'm not a big fan of headers, but I want to see what's going on. Is there something with the 3.3? I don't know. I mean, I can't get more than 380 foot-pounds of torque. Why? But you know, I'm going to try it with headers, and we'll take it from there. You guys, it didn't take long to do the first one, so now I'm off to cylinder number 3, second piston. Here we go. You know, it's fun. You know, you're hoping that you're gonna make more torque. Yeah, there's a lot of time involved, but you know what? This is the right way of doing things. We did our 8 cuts and our 8 pistons. So no balancing required, no new pistons required. We're gonna go along with the 20 thou thin gasket. I've shaved or milled the heads, not 20 thou this time. I milled them 35. The reason why, I want to bring the cylinder pressure to 180. I want to make sure I get over 400 foot-pounds of torque. So that's gonna be something to see. You know, I don't know a lot of guys doing that anyway, so you know what I mean? This is a street car, it's a street engine, it's not a race car, just a cruiser. Just want to put a little bit more torque into it. You guys tell me, what do you think? Is it gonna work? We're gonna find out.
So Nick has tried just about every trick he can think of to get the 383 making some more decent torque numbers, while not destroying his customer's budget. But the final word will belong to the dyno, where the results will be revealed.
Well, we're back here with the Weaky 383. You know, we've done a bunch of videos on it, and I hope this is the last episode. You know, the last thing I did on this was fly cut or cut reliefs in the pistons to make that little bit of clearance that I needed for the intake valve on the bullet camshaft that we put back in. And of course, you know, I also told you guys that we have another set of cylinder heads, hardened seats, brand new valves, and of course, we also had them milled down 35 thou, and I brought this time the compression up to 10.05, and I got right now 175 PSI in each cylinder. I've been trying to get 425 torque like they had stated from the factory at Chrysler, but I couldn't make that goal. I couldn't get anything near 400 or past 400. You know, and they were saying in 69 that 383 Magnum or Roadrunner engine had a 10.0 compression ratio rated at 425 foot-pounds of torque. A year later, in 1970, they brought it down to 9.5 compression ratio, and again at 425 foot-pounds of torque. Can that be possible? So anyways, right now I got real numbers. I've got my chambers, cylinder heads planed down. I did not take the block. These pistons are pretty high up in the deck. And like I said earlier, we notched the pistons to have clearance for the bullet camshaft. And of course, now we have a true blue 10.05 compression ratio. So what did Chrysler say in those days? I do not know. So I have not run it yet. I've got the manifolds back on. We also have the stock cast iron intake. We're staying with this one because this belongs to Joe with a 70 Roadrunner with an air grabber hood. So we wanted to keep the same original height on the intake manifold. And I know if we put a single plane intake manifold on this 383, we'll gain more horsepower and more torque, and I know we'll get our numbers because I've done another engine for someone in British Columbia with a 383, same cast iron cylinder heads, but we had headers and a single plane intake manifold on a 383, and we got our 425 foot-pounds of torque. But that was with headers and a big open planium intake manifold, not with a cast iron intake and cast iron exhaust manifolds. I'm trying to reach this goal, factory numbers 425. I've been having a hard time, but today I want to finalize it, and I hope, which I have not started yet, to see what I can get right now with these heads put on. I'm also testing it with my 750 HP, which later on I will tune his 750 Holley carburetor, but that will be later on. I'll do it on my own time. But in the meantime, I want to max out to see what we got here. You know, I've been working at it, and the best part, I kept everything within budget. And that budget is not just the engine, it's also his steering box, the gearbox, and the radiator, everything with the car, and of course the dyno testing. So I'm gonna get it started, warm it up, make a few tests, and then I hope that we get anything over 400 foot-pounds of torque. All right, so let's get it started, warm it up. I'll make a test just to have it heat soak. Then after that, we'll make further tests to see how it goes. And let's finalize this 383 little old Weaky, okay? Here we go. Okay, I'll put my O2 sensors on. And do not forget, this car came in here with 150 PSI cylinder pressure before I removed the cylinder heads from the car. Right now we brought it up to 175. So it's got to show a gain. Come on. So let's go for it. I have never removed the crankshaft in this engine. Why? I didn't have to. We had good pistons, and it was already balanced, it was already smooth. You know what I said? Leave it alone, let's work with the cylinder heads. Another thing to check out is this is the engine when I first got it on the dyno. It leaked oil for the first few minutes while we were warming it up and breaking in the cam. So now we're starting it again. We're gonna warm it up and let's take a look, because don't forget, it stopped leaking on its own. So today we're gonna keep checking and see if it leaks any longer. What, it fixed on its own? I'm sure, because you know I've done this job many times before, cutting into the pistons for extra clearance for the valves. I'm very confident this is gonna have no issues whatsoever. My concern is these new cylinder heads that I put on, if it will make a difference and get me over the 400 foot-pounds of torque. Just get me over 400. Don't forget, we kept getting into the 380 zone. Let's get to 400. And like my customer wants, he wants exhaust manifolds in the original intake, the way it came from the factory. I just wanted to say another thing. I did the best I can with this engine without going overboard, without overgoing with the budget. I stayed within the budget. And don't forget, you guys, how much do you want to push this engine? This is a matching engine to the car. So, and we're going to take it up to 5,500 RPM. from 25 to 55 at 300 RPMs per second. Okay, let's warm it up and then we'll take it from there. Adjust the idle. Looking good there, looking good. Okay, we got it at operating temperatures. Let's make one blast. I'll take it to 5,500 RPM. Then after that, we'll take it from there. Here we go. All set. You folks ready? And this is the end of dyno testing. You know, like I said, I put this engine quite a few times on a dyno. And I hope I finalize it today because there's nothing more for me to do. You know, I maxed out the compression in the cylinders. You want to run on pump gas. He's got the intake he wanted, the exhaust manifolds. And let's make a test and see how it goes. Let's go. Here we go. Let's see where we're at. Okay, horsepower. We're up there, 347, not bad at 5,100 RPM. We got the power we weren't looking for around 350, which is not bad. In fact, it was stated 335 horsepower. Our torque numbers, we're at 395. I'm short of a 400. Damn. You know, I can't get to 400. It's unreal. It's unreal. Okay, we heat soak the block right now, so we'll do another test back to back and we'll take it from there. The timing is where I have it set. We're gonna play around with it maybe if I need to. I just want to see 400 foot-pounds of torque. You know what? I was stuck with 380, 383 foot-pounds of torque. We're at 395 right now. That's not bad. Not bad. Just by replacing the cylinder heads. Horsepower, we're up to 347. We're up there. You know, we're almost at 350 horsepower. It's a flat torque, it's pretty good. Horsepower, not bad. Like I said, it's just a little cam. It's a basic stock. All we did was bring up the compression ratio. It's a little cam. Now, was this engine really making 335 horsepower at 425 foot-pounds of torque? I believe not. So, you know, it's got a very small stroke, does not have a lot of piston speed. So from what it is, it might be the nature of the beast. What was Chrysler at? I really don't know. No matter what I do, I can't get 425 out of this engine. Don't forget, when Chrysler rated 425, they had this intake, those exhaust manifolds. Except now, we put a little bit more lift on the cam, and of course, we brought up the compression ratio. Why can I not get 425? Or even just over 400? Now, were those real numbers, or were they playing numbers for insurance benefits, for racing purposes, or just the bragging rights to sell the car? But from a 383, don't forget, a 440 has 480 foot-pounds of torque. A 440 rated with a 10.0 compression ratio, made 480. And this little engine with less compression made 425. I don't know, find out to believe. So let's make another test now that it's heat soaked and take it from there. Same horsepower, torque readings, 397.5. Man, we're short of a 400. I just can't believe it. Maybe I'll notch the timing a little bit just to try it. I doubt if it's going to do anything. Air-fuel ratio is good. No difference whatsoever. And you got to admit that my dyno is very conservative. It's very consistent, and it is what it is. Yeah. I just can't get that 400 foot-pounds of torque. You know, I'm going to say it again, and I'll say it again. It's the nature of the beast, you guys. That's it. Okay, so, you know what? Let me just advance the time 2 degrees, and we'll take it from there. Give it another try. Let's go. I want to see a 400. I just want to see a 400. I'm off by 2.5 foot-pounds of torque. Come on, you guys. Let's do it. Let's do it. You know, I know I'm fighting for something very small, but it's just my curiosity. I just want to show Joe that I could make 400 with this engine. I just gotta see it on paper. So Joe, let me give it another try. I just advanced the timing about a couple of degrees. Maybe I'm going to retard it later on. I'm not so sure. So here we go. Did I get a 400? Come on. 399.1. Horsepower, 350. Not bad. Okay. 399.1. You gotta be kidding. Now we're up by one number. What do I do? I mean, I came so close. Come on, 390. But I did see a flashy 400 there. With the 350. You know, I don't need to go to 5,500 RPM. I'm going to drop it at 5,300 or 54. Looks like we're doing good. Let's see. You know, I gotta admit that this little 383, Weaky 383, is proving to me that Chrysler did not do their numbers correctly. That's my opinion. Look, I've been playing with this, and you know, my dyno, according to Superflow, when they came here, we did the new installation of the new electronics. It's pretty conservative and it's pretty accurate. So I think my numbers are pretty good. I'm not gonna argue with that point. So now we're gonna take it from 2,500 to 5,400 RPM. I'm just gonna let it cool down for a minute, and then we're gonna blast it one more time. Should I advance the timing one more time, or just cool it down? Yeah, here we go again, asking questions. So what do the viewers think? Are we gonna hit that 400? I'm off by one number. I just want to show Joe I hit 400 with this manifold and his intake manifold. After that, later on, tonight or tomorrow, I'll tune it with his carburetor. But in the meantime, I'm working with a good running carburetor, and I just want to max out the engine. That's what I care for. You know, I just want to give him that piece of paper printed 400 foot-pounds of torque. Horsepower is at 350, not bad. You know, factory stated 335. But the main concern is if my customer's happy when he gets the car back and he drives it and he tells me, Nick, there's a lot more power than when he first sent it here in the first place. You know what? I'm just going to advance the timing 1 degree. No oil leak. Look at that. Nothing. I can't believe the oil leak. I've never seen anything like it. When I first put on the dyno the first time, I had an oil leak while I was breaking in the cam. And now I'm heating up the oil, made test after test after test, and there's no oil leak whatsoever. And like I said earlier, I have never removed the crankshaft or tampered with the rear seal on this engine. And if somebody wants to know, yes, the cam is degreed in at 107, but with my degree roll, I ended up with a 106 intake center line. So all the folks who are asking me, what's the degree in? 106 intake center line. Okay, Joe, I'll give it one more shot. Once I hit 400, I'm giving up. I don't need to beat up this engine so much. I gave it so much beating. It is a good engine. And you know, like I said, we installed another set of heads. There's only the difference is notching those pistons and playing with another set of heads. And that's it. That's all I've done. And of course, I planed down the heads about 35 thou, brought up my compression ratio. Come on. And I can't get 425. What was Chrysler talking about? Anyways, these are the real numbers, and that's all I can say. Was it Chrysler, GM, Ford? Were they playing with numbers in those days? I'm not sure. But I got an engine here from Chrysler, Dodge, Plymouth, that I'm playing with. I've not worked with Fords. I've not worked with GMs. But you know what people say? They brought down the horsepower so they can make sales and keep the insurance companies happy when clients were buying cars and buying insurance. But in this case, I can't get 425. So you tell me what was going on. And here we go. We're going to start up and let's take it from there. One more time. I did it. Finally I got it. We got it. Same horsepower. We got the 400 mark. That's what I wanted. Okay, here we go. O2 sensors off. We got 400 foot-pounds of torque at 4,000 RPM. And we pulled out a 351 horsepower at 5,000 RPM. So 1,000 apart. And here we go. There you guys, you have it, 400. I finally got it. Should advance the timing some more? Maybe not. I think it's good enough. We're at 38, 39 degrees. I'm gonna leave it at that. I got 400 on my paper. I'm all good. My horsepower is over 350, 351.3. It's good enough. Now I just want to put it back in the car because I did drive it before I took the engine out of the car. I did drive it. And now I want to put it in the way we built it here. And let's see how it really goes. There, 400. Got it. Oh, look how smooth, George. Look how smooth it is. We're very nice. It's going to be a good cruiser. So there you have it. We finally hit the 400 foot-pounds of torque. I was hoping to get 425 like Chrysler stated back then. Like I said, I raised the compression ratio. We put a little bit more of a cam. We have it's also a hydraulic flat tappet. There are cast iron cylinder heads. Brought up the compression ratio more than the factory did. We got 400 foot-pounds of torque, and I know my dyno is absolutely correct. And there you have it. I gotta call everybody. I gotta call Manny and Philip. Tell them, hey, we did 400 on the manifolds. Yes. And let's see if it's leaking oil. No oil leak. All right. So there you have it. I think I'm gonna finalize it right now. I'm gonna just work on the next day on his carburetor to tune it up. So it's got the 750 also to put on. I want to fix the air-fuel ratio, which is right here. But this engine has the potential right now, 400 foot-pounds of torque. Might have a little bit more, who knows? But as it is, you guys, got factory manifolds, factory intake, which is a very restricted intake manifold for this engine. It's flat, it's robbing a lot of horsepower. I could probably gain 30 to 40 horsepower or foot-pounds of torque, maybe, I'm not sure. But we're staying with this because of the air grabber, and there you have it. So now if you want to call it a Weaky 383, you know what? It could be a Weaky 383 if it came from the factory. But coming out of my shop, there's not a Weaky 383 anymore. Because I know what it's got, what we've done to it. It's a street cruiser, pump gas, and it's gonna do just fine. So we want to call it a Weaky 383? No, I would call it a good performance 383 coming out of my shop here on Nick's Garage. And there you have it, guys. And thanks for watching me on here on Nick's Garage. And you guys, if you look down below the video, we have a whole bunch of merchandise that you guys can buy. So whatever you like, buy it, love it, wear it, and enjoy it. And help spread the word of Nick's Garage. And if you have some time, check out our Patreon page. We have extra content and you guys can watch it and take it from there. And we'll see you next time.